I guess it was 2011. I was working at a corporate company at that time as a senior developer. My main responsibility is building requirements and features as fast as I can, because I was the senior developer, and we call developers senior because they can build features and bug fixes faster than ever, right? So when I joined the team, I noticed that the platform, it is almost impossible to go fast, because due to rushing to catch the deadlines, we decreased the quality. It means we had no tests. Whenever we change somewhere, the other place, a place that we even cannot guess, they break. And therefore, it is almost impossible to go fast, even impossible to build big features in the deadline. So at that time, our project manager was living in another country, and I called him via phone and told him that we have to rewrite the whole platform again, because it is impossible to add new features. And after 30 seconds of silence, I thought that the connection had gone at that time, because I waited for 30 seconds, and he started to speak, and he said that, Lemi, wait a second, I need to understand. So you are telling that that your team wrote that application, that platform so bad, such a bad way that the same team have to rewrite it again, but in a good way. I said, yes, and he said, sorry man, it is unacceptable. You should have written better. So the answer, I start to realize that we are in a wrong position, wrong route in our journey. Therefore, instead of rushing to catch the deadlines, we have to slow down and increase the quality. In this talk, I would like to I point more than 10 places that we can slow down to go faster than ever. Let me introduce myself briefly. My name is Lemi. I'm a software developer. I've been coding since 2001 with Love. I'm a co-founder of Craftbase, a startup based in Istanbul. And I'm the founder of Software Craftsmanship Turkey community. I have worked at Sony a kind of 10 years, and I'm an alumni at Sony at eBay. So, in the software world, being fast is vital and critical than ever. It is not because you have to deploy your applications to the market fast, because the market is competitive. It is also because you have to deploy your fixes to increase the customer satisfaction. Customers wait not only the features, but also the fixes of the bugs that they experience. Thankfully, we should thank to Parkinson's law. So according to Parkinson's law, work expends to fill the time and resources assigned to it. So if you give 3 months to a project, it covers 3 months to complete. If you give 1 month to a project, it covers 1 month. It doesn't state that you have to stay late at night for work, but it mentions correctly. In fact, we use Parkinson's law to improve our productivity, because it's a very simple yet very efficient trick. We manufacture deadlines for ourselves to improve our productivity and to push pressure on ourselves to make focus, to gather focus on the work we do. But we have a real problem with the concept speed. We assume that going faster is directly related with giving deadlines and rushing to catch it. We add new people to the projects. if we feel that we cannot catch the deadlines. And also we start to do overtimes again and again. And doing overtime and adding that new people is not related with being fast. So that is a real problem in our minds. So rushing makes us neither faster nor more productivity. Rushing just increases stress as usual, and distracts focus and destroys productivity. Rushing is the enemy of creativity. So we have to admit that software development is done hard because it's too complex, and in fact we cannot get rid of the complexity of software development. We have to live with it. And when we push for speed, when we rush, we create an unstable environment, and it becomes unsustainable. Even though we may catch a few deadlines, a few short deadlines, in the long term and the mid-term, we will miss most of them. In fact, rushing simply doesn't work. So timesheets, team capacity planning, velocity, master plans, right? Fixed hours, such timesheets, those are imaginary concepts. What is reality is the incompetency. Deadlines, catching deadlines is directly related with the people, the competency of the people. If you have competent people, if you are competent enough, most probably you need no frameworks for being productivity at all. But let's see how it works in the reality. So Mike Beadle, you may know him already. We lost him in an unfortunate incident last year. He was one of the creators of Agile Manifesto, and before we lost him, just 3 days before we lost him, he sent a tweet, and in the tweet, Agile doesn't cure incompetence. It doesn't matter how you coach the team. If the team is not competent enough, they cannot be agile. So technical excellence is a must. So we got, at the end of the day, of course, we got legacy software. So legacy software is a kind of software, works in production perfectly. What it means perfectly, you earn money from it, and people use it. However, it needs the developers' blood and life energy to be online. And when you face with poorly written code, you jump into an endless loop of do, panic, and redo, unfortunately. So let's see a legacy code. So few years ago, while I was scrolling in the Git repository, I noticed this code. This code is yet simple and is a working code snippet. It was written with unit tests. They are all passing, and it was deployed to production, and it was working at production perfectly. However, while I was scrolling the code, I stopped here, I looked at it for a few minutes, and I thought, there is a problem here, but I don't know what it is. I opened the unit test, it is there, I run it, and it worked. I checked the production, it was already deployed to production. However, there's something wrong on it, right? So let's see. So this is a validate package method. So validate package method should validate a package object. And in that package object, so first we create a message variable. We assign null to it. Then if package is null, we assign package is null, message to the message variable, or else if the package is not null but is empty, then we assign package is not valid to the message. And we check the message string, and if that message string is not empty, it means we have a problem. We throw an exception, and hopefully we have a big try and catch, and we cached it inside the method, and we say return false. And at the end, if nothing happens, return true. Perfect. And I deleted all of them, and I closed my eyes, and I start to code by opening my eyes, of course, this line. It worked perfectly. The tests passed, and it did the same thing, even though logging is not here, but we pushed logging to the up stack. So you see, the previous version is a point of rotting of your code. So we have to fix it immediately whenever we notice. That was the legacy code. So Robert C. Martin mentions that if your software is getting harder and harder to develop, we are doing something wrong. Something wrong means we are rushing a lot. We are going too fast. We have to slow down. And I believe that in the turning points, we have to slow down. So because we need a sustainability, we need sustainable pace in software development, because software development does not end. There is no such a, we ended the development phase of this product. In 1 hour or in 1 day, we have to continue. I feel that there are more than 10 areas for slowing down. When I brainstorm, I find more places, more areas, but let's jump to each of them one by one. Okay. So first, every company looks for a good developer. We are opening we are writing posts to social media, to recruitment companies, we interact with them, and we are searching for motivated, disciplined, and passionate developers, right? However, recruitment is too important to be left to recruiters. Recruitment is also a responsibility for developers. What I see is, when you go to an interview, as a developer, first, you look for someone can understand your wordings, your concerns, your feelings. So those are the developers. So interview with developers, interview with testers, Of course, I don't mean that managers or team leads should not interview. However, at the first place, developers in a team, if you are thinking of an open position inside a team, already existing team members should join the interview process. And always ask first for the fundamentals, because even if the guy is a senior guy, fundamentals is very important even for them, because without fundamentals, developers don't create solutions, they create new problems. And always see the candidates while coding. It could be a pair programming, it could be an assigned project. Always review their code with them, because you can only understand by working together how they feel when they are challenged. And never allow the culture of newcomers dominate the existing ones. What I mean is, you need 10 developers, 10 positions to be filled. And when you hire 10 developers at one time, it means you don't have, you lose your culture, your existing culture, because culture is a combination of each individual's behaviors and feelings and individual beliefs. Therefore, you have to be slow on it. never hire more than 10% of the employees at one time, and because adaptation and onboarding is much more important than being grown in huge, with many people. So, silos and heroes, they are dysfunctions of your organization. If you see someone hero and saves the world, save your organization, save your application, it means you have to come together and identify why we needed a hero to save the application. Being a hero means you hide the problems under the carpet. Also, there are two cures I see to eliminate the silos in the company. One is knowledge and experience sharing continuously. The other one is conversations and discussions. So first, lunch and learn sessions. I've been organizing lunch and learn sessions since 2010. It's more than 200 already. So every week at the same time, same place, you gather and one of your colleagues share something important according to them. And it should be every week. So who does this? Who does such a sharing session? Perfect. 1, 2, 3, 4. A kind of, okay, perfect. I really advise to start this ritual and also mob programming. So mob programming means one driver and many navigators, and you can switch the keyboard or computer between the developers. However, I really advise mob programming because it's all about sharing discussions and doing conversations. What we do is every week we spend almost half of our day with the mob, with the team, and we touch every single point, single task we have to do in that week. So it is just after sprint planning. So sprint planning takes like 2 hours, and after it is completed, we go into the room and open the IDE and start to code, and we spend half an hour each task, let's say. If those tasks are very straightforward, you skip. However, the discussions are very important, so not everyone is equal to each other. Those are juniors, some of them are juniors or newcomers. So some of them are senior, but coming from another sector. So we have to share our knowledge. The discussions is much more important than going fast. Who is doing mob programming effectively, like every week, a kind of? I really recommend to do mob programming, to taste mob programming, and inspect and adapt, of course. So if you have a dependency to another team while doing your work, if you wait some output from another team to complete your task, which one can be the option, could happen? So maybe your organization has problems with DevOps culture. What I mean is DevOps culture is removing dependency between teams. Each team should be competent to build their software and to deploy to production without the need of platform engineers or the other teams. Or may your team has a lack of cross-functionality. Do you have front-end team, back-end team, Node.js team, Java team? If you have such a teams, it means you have no cross-functionality. Or do you work in a project or a product? So a project means someone called the project manager should check the state of the project again and again to identify the problems. However, if it's a product, The whole team should be capable of building it, defining the design and architecture, and testing it, and deploying to production as well. Or do you have a proper design or architecture? So you have a REST API, you have many REST APIs, okay, but do you wait another team from another team to build a REST API before you start? They have to complete first, and you should start later, right? If that is the case, we are doing something wrong. We have to slow down, and we have to build a more proper infrastructure, and we may think about building external verifier stub test or consumer-driven contract testing to eliminate the dependencies. So all of them could happen in your team. So we are, as developers, we are really trying to build successful products, and we have to learn a lot of topics, right? From branching mechanisms to deployment strategies, from cache management and monitoring and traceability, there are tons of topics we have to know. Of course, we are living in a team, and many people are there, and each individual may have good knowledge on few of them. However, those are the topics we have to learn. Then, is it sufficient to build a successful product? No. Unfortunately, we have to know our domain. The sector needs more domain experts than Java experts or development experts. Because without knowing the domain, you cannot build proper solutions. If you're working in a finance sector, you have to know finance. If you are working in a ride-sharing sector that I work, we have to know the dynamics of ride-sharing. Why the drivers can feel unhappy when X, Y, Z issues happen, and how can we eliminate the inconsistency and such. We have to learn the dynamics of the domain. If you are working on an e-commerce platform, you have to know the dynamics of the e-commerce, of course. I feel it is the first point. We have to slow down and improve our knowledge. And please make your developers on call, always. Most of the time, developers work behind the walls without touching the customers. It's safe, it's warm. Customers and operation people, they're fighting with each other because there are bugs on the production, and they have to explain, the operation people, they have to explain the reasons why there's a bug here, and they say, I will escalate this solution to the technology team most of the time. However, when you start to touch the customers, you start to understand the value of your output. We call it, in my company, Batman, Robin, and Alfred. We have 3 on-call developers, and every week we change the people. Batman is the more experienced one, and Robin is the newcomer, guys, and Alfred is most of the time the front-end guy. He can do anything, everything, he knows everything. And yeah, before building your application, your solution, you have to design your system. On where? On whiteboard, on paper. You have to document it, because this should be the single point of truth before starting. But what should it have? It should have the interactions between microservices, between the customer and the microservices. It should contain the notifications. It should contain anomaly detection mechanism flows. It should contain how we can cancel the payment. So it is really important before building our food delivery system, we draw this system document on the wall, and we start to develop. Of course, it changed, but it is the very efficient starting point. So, microservices architecture is a kind of de facto in these days, right? Yes, a kind of de facto. However, if you are not experienced or you have a few experience about microservices and the cloud, it's a kind of hell. So let's be pragmatic. So this is a real interaction diagram of our system 1 year ago. It's a kind of hell. There are lots of dependencies between the services, the microservices, and there are some, whenever these microservices not responding, we had to shut down the whole system because we have to restart one by one again and again. So what we need to do? First start with a monolith, but how? The modularity is the real answer. We have to focus on modularity first, because if you cannot write well-crafted monoliths, what I call is modular monoliths, how you can say that microservices can save your problems or resolve your problems? So, Martin Fowler sent a really interesting post about monolith-first strategy for building microservices. But monolith is a kind of anti-pattern, we feel that, but how we build well-crafted monoliths and how it can have impact on building well-crafted microservices, I will jump to it. So, in the software architecture, in the 90s, we write lots of spaghetti code, right? And in the 20s, it becomes a lasagna code, the layered architecture, the presentation layer, the business layer, and the persistence layer, and you always write user manager, user controller, user service, user repository, user table, user, and you start to refactor something, and you have to change something on the controller, service, manager, user utils, user handler. You always use the layered architecture. And at some point, microservice architecture is in place, and it's very popular. Then it is the ravioli-oriented programming architecture happens, which means it's a kind of anti-pattern, because in the ravioli, they are not really interacting with each other. They are there individually, but they don't really interact with each other. And the next one, is it pizza-oriented architecture? I don't think so. It's a Beiti-oriented architecture. So Beiti is a kind of kebab. It's a wrap. It's a wrap, but it is splitted, so it is cut into pieces. However, with the sausage, each individual cut has some interaction between. So there is a meat inside, and then the bread or lavash outside. So I call it, it's time for Beiti relay-oriented architecture. So what I call, so we can, of course, visualize it as hexagon. So this is a hexagonal architecture diagram. There are two hexagons, in fact. However, it is not really a hexagonal. Alistair Cockburn gave the name hexagonal, even though it is not a hexagonal. So here, there is an internal hexagon, which is pure language, which is the safest place on earth for a developer, because the internal hexagonal is framework agnostic. You are writing Java, then all you need to do is writing Java here. You don't need anything special. So you can use design patterns. Hey, do you feel that we are losing using design patterns? So for years we write user controller, user manager, user service, user repository. Hey, where is the design, the need for the patterns? We always write again, and we copy, we cut, and if you find the long method, we copy a big part of it, cut it, and put it to a user util class or user helper class. So that is the main anti-pattern. So here, this is the domain part. It contains business logic. This is the heart of a microservice. And all you need to do is, if you need to go to Stripe for doing payment, all you need to do is writing a payment port, which is an interface. You do not need implementation for Stripe, because today it is Stripe. Later on, it could be Klarna. Later on, it can be, you can add Adyen. So first, all you need to do is writing interfaces as the ports for interactions to other hexagons or other third parties. So with here, here this is the primary adapter, this is the secondary adapter area. So in the secondary adapter, you can connect to any third party technology or any other hexagon. So this is an SMS provider, database, mail server, Klarna, Stripe, whatever you do. Another API on the third party. This part is the entry point. It's kind of like batch jobs, GUIs, user interfaces, command lines, and such. And controllers are here, and GPA adapters are there. Okay. And you can slice them into pieces, and like a slice of pizza. So here, each of them can be a feature of your microservices. So this can order, payment, and mail, search, caching. So all of them could be, each piece could be a different feature. So I will show the hexagons in practice. So assume that we have more than 20 microservices, and each microservices is an hexagon. So here, assume that we have an order API. Order API is a microservice, is an hexagonal microservices, and inside the hexagonal, this is the directory. You have a domain and infra directories. Domain directory, it's a place without any dependency to any framework. It is pure Java, pure Groovy, pure Kotlin. And in the infra has a dependency for domain, because business logic is inside the domain, and model is inside the domain. Infra contains the slice, pizza slice. So here, for example, here you see there are primary and secondary adapters. Here we have order, partner commission invoice, cancel result. Those are the slice. And on the secondary adapters, we have account, anomaly, and campaign, and such. So remember, please notice that the names of the folders, you cannot see any controller directory, you cannot see any service, any repository, any module directory. You can only see directories showing the names of the functionality. Do you remember yesterday, Sebastian Dasher? And he says, screaming architecture. Whenever you look at your microservices, the inside, the internal, you should understand what the microservices is doing. Okay? And also, you can write it, you can build it via TDD. TDD is a very cool practice for building hexagonals, because it's really, really easy. Here, for example, we have component tests, contract tests, integration tests, unit tests, and such. we all build our hexagonals via TDD. And when we come back to our hexagon, each slide can be extracted to build a new hexagon. So hexagon contains pieces for new hexagons. So here you have the monolith, then you extract the search piece to another hexagon, and it becomes a new microservices, and for payment and for accounts. Okay? It's that easy. And do you really want to release and deploy multiple times a day? Which one? Do you release and deploy multiple times a day? Cool, a few people. I'm not sure if do we really need that, but if you think that you really need that, as we do, you have to slow down. You have to slow down and invest your practices. So this is a journey, by the way. There are a 3-step journey as far as I see. So from weekly releases to daily releases to multiple releases in a day. So this is a 3-step area. So first, Git flow is a kind of de facto standard for the first start. So you have a master branch, develop branch, release branches. Every developer gets a feature branch from develop branch and merge back to develop, and develop branch is the next release branch. And whenever you want to release something, you make the prepare release, you create a release branch, you freeze the feature, adding feature, you only do bug fixes, then it is completed, then merge back to master and the development branch at the same time. So this is the Git flow. Git flow means you have excessive number of branches, and you have to you are slowing down for deployments, and most of the time you have a few tests, no tests, and do CI continuous integration means building packages. So Jenkins is just for building packages, not for running tests most of the time. And the development definition of done for Scrum users, so developed and tested at local. So the second phase of the journey is what I call as master feature branching. So in the master feature branching, you have a master, and all you do is creating a new feature branch, develop on it, and open a pull or merge request to the master. And the main activity is the code review here. So you can do pair programming at some point, but the main activity in that stage is the code review. So the definition of done is deployed to pre-prod environment. You can call it staging or pre-prod or preview environment, but it should be tested there. However, what you can do is you can achieve like once a day, a release and deploy to once a day, because deployment is a kind of costly, expensive. And the last step, what I call is no branches stage. Means you have only one master, you have no pull requests at all. Why do you need pull requests? Because someone should look at your code and validate, and it should write comments or talk on it. So what if you do active mob programming or actively doing pair programming? Not full time, of course, but in fact at some point. And when you implement feature flags, it means it can be backward compatibility always. And if you have elegant test suites, and you can make each of your commit deployable. And if you have an acceptance test or feature test, if you have an elegant test suite, you can achieve that. So definition of done of this stage is the real definition of done, which means you deploy to production and you never look back again. So I've been writing tests. People call me like a test freak, because I really, at some point in my career, I really dedicated to write 100% code coverage, and I achieved it. However, I feel that writing tests after your production is kind of weird because you write your test to pass. That's weird. I really would like to do, what I need to do is, I would like to write my production code to execute the specification. So tests should be specification. So TDD has more refactoring and more thinking than coding. Do you remember Sebastian's yesterday talk? He said, think first development. Think first development could be TDD also. And more simplicity than elegancy. So TDD is slowing us down, yes. So Joe Ransberger, he answered it. So you are worried about TDD to slow down to your program, to your programmers. TDD simply does not. They probably need to slow down. You need slowing down. TDD does not make you slow down. You need to slow down. So I had a quote from Uberto. He has a perfect quote. First, I thought TDD was about testing. I thought, yes, it was testing. Then, that was about designing. Yeah, I thought at some point in my career, yes, I thought that. Now I'm convinced it's about thinking at a sustainable pace. Perfect explanation. We have to think at a sustainable pace. So writing tests is of course, unit test is a subproduct of TDD. However, we need to write tests after your production code. Those are functional tests, integration tests, and security tests, performance tests. Please do not calculate your code coverage. It's not worthy. Just delete your brittle tests. If a test is there, but it does not mean anything, just delete it. Please do not push yourself to increase the code coverage. You push yourself to feel more comfortable while developing. So, we have more than 25 microservices in production today in one application. In another one, it is a kind of 20, 25 too. And Kubernetes, if you are using Kubernetes, it means that pods, they stop and they start by themselves. So you cannot have an ownership on it. I mean, you cannot decide if it really wants to scale up, it opens new pods. If it feels that you need to scale down, it closes pods. So it means there might have some inconsistency in your system. Pushing consistency to your system is very expensive. You have to rewrite mechanisms and anomaly detection systems. Today, what I'm working on is Scotty. Scotty is a kind of Uber with motorcycles in Istanbul. And the application, more than 10,000 trips happen in one day, usually. And during trips, due to bugs, due to problems on the infrastructure or in the code itself, we lose states and we face with inconsistencies. Hopefully, we have anomaly systems that detect the anomaly and solve it immediately. If you want to go fast, so there's an African proverb, if you want to go fast alone, go alone. If you want to go far, go together. Lovely. But there's a version for software development. If you want to go fast, go with a pair. How it is possible? Pair programming, we feel that we are slowing down, right? Yes, we are slowing down. However, According to the researches, scientific researches, I read lots of papers about pair programming, and in the researches says that if you are not at the beginning or at the end of your project, which means on the big portion of your project, if you are doing pair programming, you are building faster. You are fixing a bug faster than when you fix the bug individually. So if you really go fast, even though being faster is not a real aim for pair programming, however, scientific researchers mention that you will go faster. If you want to go far, you go with your mob, because we really need sustainability. Software development never ends. Therefore, new people will join to your team and you will move to another team as a newcomer. Therefore, sharing knowledge, collaboration is the first strategy for your organization. I noticed a very important tweet in the few years ago. Andreas mentions that I don't want to write just code works. I want to write code that is clean, that is maintainable, that is understandable, and well tested. I want to feel responsible and feel proud of the code that I wrote. Lovely. First, we have to admit that working software does not have to be well crafted. Only good professionals can build well-crafted software. And only well-crafted software lets you build features faster than ever, my friends. Thank you for listening. I guess I have few minutes more. Anomaly detection, yes. For example, during the ride sharing, imagine you are Uber, you are building an Uber application. People just enter their credit card information to the Uber app, and when you call someone, the Uber ecosystem just gets the payment from your credit card. However, due to an anomaly, like during the processing of your application throughout the journey between microservices, due to a bug or due to an infrastructural problem, you may lose the control of that flow. You may lose the control of that state. Then it means you have to cancel that payment, cancel that trip request. However, you lose control. Because no system is perfect enough to catch everything, to catch all the states effectively. Therefore, what we do is there is an anomaly jobs triggered via cron or automatically, and they're sending queries to the database, to MongoDB, to Redis, to the places where you keep your data, and try to detect the anomalies, like a trip request with more than 2 drivers matched, or like a driver with more than 10 users available, or like. So whenever we find the anomaly, we start to identify the reasons. So we have 4 or 5 scenarios, and for each scenario we find the real reason, and according to the reason we pay back, we cancel the payment, we make the driver free to accept new requests, new trip requests, also fix the state to keep the data consistent. That is the anomaly detection from me. Any more questions?
So you haven't mentioned very popular keyword Agile. Do you use it or something else?
Which one?
Agile.
Agile,
or
yeah.
Scrum. How do you organize
Sure.
tasks? Work?
I've been running sprints. I've been doing, let's say, Scrum since 2007. So it's like 12 years old. And every week I do planning. Every week for the 12 years. Of course, in few years I stopped due to the consultancy issues. However, so Scrum and Agile frameworks, they are efficient if you feel the real necessity, if you feel the real reasons behind the rituals, behind the mindset. If you really don't need the necessity, you really can make these rituals and make these frameworks useful. Therefore, for example, in my team today, we have no Scrum Masters. We don't think that Scrum Master is a required position if the team really feels the necessity of going structured, believe in collaboration, and believe in the real reasons behind the rituals. Therefore, everyone is a Scrum Master, let's say. It's a long topic. I really would like to chat afterwards. Okay. Any questions? Okay. Last questions, I guess.
Yeah, you mentioned organizing meetups to share the knowledge and grow the competence of your team developers. How do you encourage people who are passive by default to come to such meetings and like do the presentations or just listen?
Yes. So attending to a lunch and learn session is optional. It's optional. So anyone can attend or leave or could not attend. That's okay. But talking at lunch and learn sessions is mandatory, which means I go to a junior, a new graduate guy, or my colleague, and ask him that I want you to talk, to share your knowledge, your experience, something valuable for you, to us, because we feel that, we believe that what you will share with us, it will be valuable for us too. So just talk in front of us, share your ideas, share your thoughts, even though those ideas and thoughts are just learned by you a few days ago, it doesn't matter. The only matter is collaboration, sharing. So what I always, every month, at the beginning of every month, I just talk around my colleagues and ask to get a topic from them about for the lunch and learn, and I expect everyone, including product managers, testers, analysts, even the human resources specialists, I go them and ask for a topic to share with us. Topic is not the important. Sharing is the main mindset there. So whenever it starts to execute. So 200 lunch and learn sessions, one after another, is going really well. So you can do that too. Okay. Thank you very much for coming. Enjoy the conference.